lesson 7-1, multiplying properties of exponents. Let me just step back a second and say that chapter 7 is going to be about exponents and exponential functions. So we're sort of changing gears for a minute. We aren't going to be doing any graphing. It's really going to be all about solving these functions. So, and first reminding ourselves what a monomial is. So that's what we'll be doing today a little bit and how we work with monomials. You'll remember we did talk about these last year. We'll have two vocabulary words, monomial and constant. So let's get on and see if we can find those definitions someplace. Okay, a monomial is a number. It's a variable, and it's the product of a number of one or more variables. So it's a number, a variable, and the product of a number and a variable. And there's two things it cannot have. It can't have a negative integer in the exponents. Okay? So let me rewrite that because they're saying it has a non-negative integer. There are two things it can't have. Can't have a negative integer for its exponent, okay? It also can't have a variable in a denominator. It can have a fraction, sorry, bad spelling. Okay, so in this case, this is a monomial, but the denominator is a fraction. In this case, the denominator is a variable. Well, C could be 0, right? And division by 0 is undefined, so that's one of the reasons it can't have it. Also, if you look at this one, W times V over 234 cubed, we could rewrite that as W times 1 over 234, right? Times V, and all of that is cubed. These two mean the same thing, okay? So that's why that one is a monomial. If it has a variable in the bottom, it's not a monomial. A constant is a monomial that is a real number. A constant is a monomial that is a real number. The monomial 3x is an example of a linear expression. That means when you graph it, it's going to be a line. That's because the exponent is 1. The monomial 2x squared is a non-linear expression, meaning it won't graph as a line. Okay, it's going to graph as something else, and we're going to learn about that eventually. But for now, it's non-linear because it does not graph as a line. And the exponent is a positive number other than 1. So 3x is a monomial, right? That's linear. And 12x squared, where the exponent is something other than 1, is nonlinear. All right, so just remember that. Okay, let's look. Some of your homework's going to be identifying monomials. So let's just look at these. Is 10 a monomial? Yes, 10 is a monomial because it's a constant, right? It's a real number. So we remember that monomials are numbers, variables, and products, and positive exponents, okay? Is f plus 24? No, because there's addition. There are no operations in a monomial, right? So you can think of it this way. There are actually two terms in there. There's f and 24. But so no addition in monomials. 3, C, we have h squared. Is that a monomial? Yes, because it's a product of variables. And if you'll remember, h squared means h times h. So it's a product of variables. And j is a monomial because it's a single term, right? Okay, so that's not too bad. Just reminding you, just refamiliarizing ourselves with some variables. Okay, here's some guided practice. Try these problems. Pause the video and start back up. While you're doing that, I'll take this time to remind you to take good notes. All right. Powers, exponents, and bases. This is just a little refresher, quick refresher. I wasn't even in the book. I just thought I should remind you. A power is the whole thing. All right? It's when we express something in a power. The exponent is, oops, that's not going to work. The exponent is n, is the number that's being the number of times we're using the base, right? So if we had 4 to the third, right? 4 is our base. 3 is our exponent. Base, base, all right? Now we can look down here and see, oh, actually, where they're using 3 to the fourth. So in 3 to the fourth, we know that that means 3 times 3 times 3 times 3, or 81. So there are 4 factors of 3. Okay, so if you know that 2 to the power of 2 means 2 times 2, and you know that 2 to the power of 4 means 2 times 2 times 2 times 2, how many factors do we have? In the first one, we have 2 factors. In the second one, we have 4 factors. So 2 plus 4 is how many factors of 2 do we have? 6. So the other way to write this is 2 to the power of 6. Because 6, the exponent, is telling us how many factors there are of 2. Let's look at another one. We have 4 to the power of 3 and times 4 to the power of 2. Well, how many factors do we have of 4? We have 3 here and 2 here. So how many factors of 4 do we have altogether? We have 5 factors of 4. So how else would we write that? 4 to the 5th. Okay, and here it is as a key concept. To multiply 2 powers that have the same base, they have to have the same base. To multiply 2 powers that have the same base, add their exponents. Okay? So a to the m plus, or times a to the p is equal to a to the m plus p. Right? So let's look at a number 1. So if we have 4 to the third times 2 to the second, right? Oh, let's have the same basis. Let's make our life easy. My bad. Plus times 4 to the second would be 4 to the 3 plus 2, or 4 to the 5th. Okay? Don't be very careful. This is addition. We're going to do something else later that's going to be multiplication, so keep it straight in your head. All right, let's look at an example here. We're going to simplify these expressions. 6n to the power of 3 times 2n to the power of 7. So what we're going to do to simplify these, we're going to break them down a little bit. We're going to say 6 times 2. Remember, multiplication is commutative. You can do it in any order, right? So I'm going to move the 2 over here. 6 times 2 times n to the third times n to the 7th. All right? So now it's a little easier to look at, and we can think, okay, we have 12 times n to the 3 plus 7, or 12n to the 10th. Easy enough? Okay, let's look at this next one. B, we have 3pt cubed times p cubed t to the fourth. Okay, let's break it down. We have 3, well, it's really times 1, right? And then we have times p cubed times t to the third times t to the fourth. Okay. Take your time, spread this out. Don't get in a rush. It's a really easy lesson to make careless mistakes on. So we'll end up with 3p. We have, how many p's do we have? Not 3. We have 1 here. So that's 1 plus 3, or p to the fourth. And t to the cube times t to the fourth, will 3 plus 4. It'll be t to the seventh. And that's it simplified. To be simplified, no fractions in simplest form, one exponent of or one variable. You know, you couldn't have p's twice. You can just one set of p's and one set of t's, okay? Then it's simplified. What's our study tip up here? A variable with no exponent or coefficient can be assumed to have an exponent and a coefficient of 1. So, for instance, that's what we were talking about with that p. Excuse me, that p right here, right? It really has an exponent of and that has an exponent of 1 and a coefficient of 1. Here's your guided practice. Pause the video. Try these two. Let's see how you do tomorrow or whenever we have class next. Excuse me. Okay. So there's another thing where we're multiplying powers by powers, right? I mean, so not multiplying variables, right? So here we have 3 squared to the power of 4. So powers, products of powers, all right? So in that case, you have 3 squared. We have another 3 squared. We have another 3 squared. We have another 3 squared. So how many factors altogether do we have, right, of 3? We have 2, 4, 6, 8. So in this case, it's 3 times, and if it's a power to a power, it's going to be multiplied 2 times 4. Remember before we did 2 plus 4. This is 2 times 4. So that's 3 to the 8th. Here's another example. We have r to the 4th cubed. So we have our 1r to the 4th, we have another r to the 4th, and we have another r to the 4th. So that's 4 plus 4 is 8, plus 4 is 12. So in this case, it's r to the 4 times 3, or r to the 12th. Okay, so to find a power of a power, you're going to multiply the exponents. To find the power of a power, you're going to multiply the exponents. And here's a good study tip, I think. If you're unsure like which to multiply or when to add, you can always write it in expanded form. You can always go 4 to the power 3, 2. That means 4 to the third times 4 to the third, right? And figure it out in long form. That's that study tip. That's not a bad thought. Okay, let's try this one. Let's simplify 2 cubed to the power 2 to the power 4. Okay? All right, so we have 2 cubed to the power of 2 to the power of 4. So we're going to break it down. We're going to go inside, like with all parentheses, we go inside first. So 2 to the 3 times 2, right? 3 times 2 is 2 to the 6. And now that, I shouldn't do it that way. Let's not do that equal sign. My bad. 2 to 3 times 2 to the power of 4. So that'll be 2 to the 6 times 4, which is 2 to the 24th. And there's your answer. Here's your guided practice. Pause the video. See if you can do this problem. Start it back up. Okay. We can use products of powers and powers of power property to find the power of a product. Boy, that's a lot of P's in one sentence, isn't it? Instead, let's just look at these patterns and see what we have. Let's look at a couple of these examples. Here we have TW to the power of 3. Well, that means there are 3 of these TWs. There's 1, 2, 3 of them, right? So how many red T's are there in there? There are 3 red T's and there are 3 WT's. So the solution, or the simplified expression here, would be T to the third, W to the third. All right? Let's look at this other one they've given us. We have 2yz squared to the power of 3. So we have one 2yz squared, we have another 2yz squared, and we have a third 2yz squared. So how many 2's do we have? 3 of them. How many y's do we have? 3. How many z squareds do we have? 3z squareds, okay? So we have 2y cubed, right? And z to the 2, 4, 6. Oh, 2, excuse me. 2 cubed, my bad. And simplified, 2 cubed is what? 2 times 2 is 4 times 2 is 8. Y cubed z to the 6. Okay? All right. Let me go back there. I think this slide might be out of order, but we're okay. Okay. Well, we'll just review. To find the power of product, find the power of each factor, and then multiply. All right? Well, actually, that's just what we just did. So it's this. So first you're going to find, we have a and b to the mth power. That means a to the mth and b to the mth. Okay? It's that simple. Just looks complicated, and you'll get good at it. Just don't get careless with it. Be very careful. All right, let's look at a problem. Express the area of a circle as a monomial. Okay, area of a circle we all know is pi r squared, right? And in this case, the radius equals 2xy squared. So a is going to equal pi times 2xy squared to the power of 2, because this is the radius r, and it needs to go to the power of 2. So to find the area of this, we go pi times, how many of these guys do we have? We could do it long form, 2 times 2, x times x, and I'm running out of here, y times y squared, right? Okay, so a will equal pi times 4 times x squared times y to the 4th. And you would probably actually reverse the order for your final answer where you put pi at the end. And you don't have to multiply out pi, you leave it as pi. Okay, here's some guided practice for you. Good luck with that. All right, remember, in simplifying expressions, we combine everything that we can combine and use these properties. Okay, so here we go. To simplify expression, each variable base appears exactly once. All right? There are no powers of powers, and all fractions are in simplest form. So you aren't going to have b squared times b to the third over 4, right? That would not be in simplest form. We'd have to change that to 1/2 to be in simplest form, b to the 5th. All right? So only one variable, right? No powers of powers, and fractions in simplest form. Okay, let's try and simplify this expression. Again, the study tip just says to make sure you go inside first, as far inside as you can get first. So the first thing we're going to do is rewrite what we have that we're not going to deal with at first. 3xy to the fourth, okay? We'll leave that like that for right now. And then we'll go in over to this one, to here, and go minus 2y, and this is going to be to the power of what? 6, okay? Okay, now our next, so we have 2 times 3 is 6. So we got that one taken care of. Okay, now let's think about 3 times negative 2, right? Oh, my bad. Excuse me. 3 to the power of 2. Let's look at that. We have 3 to the power of 2, x to the power of 2, and y to the power of 4 times 2 is 8. Very good. And negative 2 to the power of 6, that'd be negative 2 times negative 2, you got it, right, is 64. And I'll give you a little, well, let's just leave it at that. It's 64. Negative 2 times negative 2 makes a positive 4, and so on until you find out, do that 6 times, and you find out it's 64, y to the 6. Okay? Now, what can we simplify here? Well, 3 times 3 to the power of 2 is 9 times x to the power of 2, and we have how many y's do we have? We have times y to the 8th plus 6, right, times 64. So 9 times 64 we find out is 576 times x squared, and y to the 8 plus 6 would be y to the 14th. And there we have that simplified. All right, it's a little bit like doing a puzzle. Do it a piece at a time, and with practice, you'll get better at doing this. The hint I was going to give you is if you have a negative number, and we might remember this from me saying this from last year, if it's an odd numbered exponent, your answer will be negative. If you have an even numbered exponent, your answer will be positive. That was my little hint I was going to tell you about. Okay, we're one more slide, guys. There's your guided practice. Good luck with that.